Alright, so here's the B2 almost all back together. Last time we saw most of the components laid out on the bench. Um, but yeah, that's pretty much all put back together except the top cover. Before I put the top cover on, I wanted to share some details and some of the progress that I made since last time, some of the additional changes and some observations of the rebuild. And so outside that, I will in this video I will try to walk you through a brief description of some of the just basically health tests that I go that I put all my rebuilds through before I move them into my listening space. This particular area is probably going to spend another week or so, maybe 2 weeks on me listening to it on different types of music, and basically I'll call that testing, but it's me enjoying the unit more than anything else before it goes to its owner. Alright, so let's start on cosmetics first. Unit is pretty clean. It was pretty clean to begin with, except that spillage from the capacitors, maybe a little corrosion here and there. But on the front plate, there's some marks, but I will not consider that sufficient reason for me to refinish that front. Chassis has been re-zinc plated again, as I mentioned last video, and top cover corner has corners because it was back and rear. You can't really see it, but it's all been refinished. It's beautiful, looks like new. All right, let's talk about the inside. Starting in the rear, power supply, as I mentioned, all fully rebuilt. Main caps are new. The wires I changed to silicone wires for increased flexibility and make sure they don't become brittle as the plastic vinyl cover original wires sometimes do, and they the mechanical connection fails. Same with this wires for the VFET board. Those are replaced as well. I made sure all my critical connection, the 85 volt supply, is also solid. The VFETs obviously I cleaned and I re-greased with thermal paste, reassembled. I even changed this ground wire for what it's worth. Obviously the driver boards have been fitted, and on the front of the amplifier I replaced the light bulbs with LEDs. Quick mode that I did on the back of this board in here, can't really see it. And then I have the selector board, which we're going to be talking about maybe a little more granular level in about a minute. I also intend to talk about the accuracy of this boom meters on the Yamaha B2, which is it's pretty remarkable. All right, so let's see what else I have on this bench right now. I have an audio analyzer that I plan to use to do a quick test on this amplifier. I have a oscilloscope that I'm going to use to look at the quality of the sine wave. It's flickering a little bit because of the refresh rate. I have a couple of multimeters set up on volts AC hooked up directly to the power output of those the VFET board. And so what I will, obviously I've adjusted already, I'm not going to go through the full adjustment. Maybe I'll do a different video some other time with in-depth adjustments and more details, but this unit has been adjusted. Obviously, I put it back to factory specs, plus on the idle current, I went up to 50 millivolts instead of 40 millivolts. 50 I find it to be the sweet spot for the Yamaha B2. Based on sound performance versus heat output. Going much higher on that idle current would probably generate a lot more heat than warranted for very marginal sound improvements, if any. 50 millivolts seems to be the sweet spot, and I'm gonna leave it at that. I keep my amplifiers that way too on my B2s. Alright, that said, this analyzer, obviously it's hooked up to both of the inputs. and both of the outputs. This is a dual channel analyzer, so we could look at in parallel at both channels. I have a dual channel oscilloscope here that's going to look at both sine waves. 8 ohm dummy loads, ready to take some heat. And my analyzer is set up right now so that when I turn the dial, it moves about 10 dBs of output, and the input affects about 10 dBs of output in my amplifier. So you'll see the precision. I intend to show you the precision of this VU meters with that test, which have been adjusted. So let's go ahead and my analyzer is hooked up to input number 1, which is basically a straight through path all the way to the driver boards. Input number 2, it would route the signal via the pots, which are actually step attenuators. I'm not gonna go through full detail of or show a full demo of this new modded selector board at this time, but I may do that in a separate video. But it will be enough for you to understand that basically this has solved the problem that that B2 has with the selector board. All right, so let's turn the power on. All right, right now this unit is set at, there's some signal coming into it. It's about minus 60 dBs. All right, minus 50, minus 40, minus 30. So that's about let's go to minus 20, which is about 1 watt. And why do I wanna talk about let's see. All right, there we go. All right, a 1 watt. It's because 1 watt is about that frequency is for two things. First of all, at low power output, the amplifiers will show you all their dirty secrets. This is when you will see most of the distortion happening, at least for most designs. Also, at 1 watt is where a lot of us, at least myself, do a lot of listening. So, 0 to 10 watts probably if I don't want to shake the house. But 1 watt is pretty common to do listening at night or in quiet time when you don't want to disturb the rest of the family. So, for those two reasons, I would like to make sure that the amplifier is solid. Starting at this power output, and so the total distortion for this amplifier at 1 watt is 0.06, 0.07, which is very low. I think the manufacturer rates this at 0.008, but I think at 30 watts. And at 1 watt, I'm not sure what the manufacturer tests for, but this you'll see as we go up in power output that distortion is going to be much lower. And so let's look at this. So how do I know it's 1 watt? Well, I have about 2.8 volts. If you look at Ohm's law with 8 ohm load, that's about 1 watt. And if I look at my sine wave, let's look. These are pretty clean. So both channels. I'm sorry about the flickering, but if I were to move this and stack them on top of each other, they are perfectly matching. This amplifier, just like this, puts out a beautiful sine wave, well matching between the two channels. Let me put this down a little bit because we're gonna crank that volume up a little bit. All right, so let's move up another notch. That's 10 watts right there, approximately 10 watts. Again, how do I know it's 10 watts? Because I have about almost 9 volts there, 8.9 volts, which is roughly 10 watts. So this is pretty accurate. Same with this brother right here. And the THD went down substantially, obviously, and this is where it's going to remain for most of the output. I mean, actually, just right above after 1 watt of power output, the THD drops significantly. This is total THD, so it's THD plus noise. This is just the THD, which is just slightly lower. If you look, let's see. Oh, one channel is a little high right now. I'm not sure. It was not like that earlier, but fluctuates. Maybe one of my crocodile alligators in the back is not fully hooked. But anyways, I would call this 0.003. That's low. That's less than half of the factory rating. I don't know if I mentioned I'm pumping in a 1 kilohertz signal. I tested this, is pretty stable across the band. I won't go into an in-depth frequency response test and all that, not on this video, maybe some other time. But let's keep on looking at this. So now that's 10 watts, and if I go another 10 dBs, it's gonna go to about 100 watts. And so now at 100 watts, and how do I know it's 100 watts? Because it's about 28 volts AC here, 20 point something, 28.9, I think. It's probably exact. So this is channels, as you could see there, pretty well matching. Let's look at the sine wave. Wow, look at that, how beautiful. Just as it was at a 1 watt. So perfectly matched sine wave. So if I'm to match it, it's just, look, it's just beautiful. So we have a very stable, very well performing amplifier here. And so but I also found out that this thing actually taps out at about 130 watts, 136 watts, about 33 volts, 33 volts AC. So it's rock solid. This is at 100 watts, so look at the distortion level. It's about 3%. Both channels. Oh, no, let's look at total. Yeah, it's about the same. It's about 0.003 of a percent. Let's see. Yeah, so that's very good. That's less than half of the factory rating, and obviously the amplifier does a little better than in terms of output. All right, so again, about these meters, I know you realize that they're so precise. You know, obviously my instrument is very precise, but these meters aren't supposed to be lab instruments, but they act like it. They're very precise. In my view, they are some of the most accurate analog voltmeters I know of. And these are even better than, well, not better, but I would say that they take the cake from the B1. The UC1 and the B1 uses the same actual instrument, but the actual control board, the voltmeter driver board in the back, has only 3 adjustments per channel, so 3 bands per channel versus 4. If I remember correctly, I think it's only 3 in the UC1. Versus 4 on the B2. So from that perspective, I would say that the B2 takes the cake. So I'm pretty pleased with the way this unit adjusted and the stability of it and the quality of the sine wave. I'll be frank with you, I did take a quick listen. I couldn't resist, and it just sounds sublime. I mean, I just love the sound of B2. All right. But let's talk a little bit about the selector board before I end this video. So selector board basically resolves the Achilles heel problem, the weakness of B2. With this selector board in place, basically all the cracking, the popping, the uncertainty of is it gonna switch channel, is it gonna switch input, that's gone away. This thing works like a charm every time. You could, this is selector input. Obviously the meter would react to that because it's the source that's being switched. These are speaker off, and the speaker output selector. This will not affect the meter, but this should affect my scope right there. So first, let me switch this back and forth and see what the scope does. Let me get a little bit better resolution on this. Ooh. All right, there we go. On the scope. All right, there we go. So let's see. I'm switching right now. I'm going to be switching the input 1 to input 2. You could do it all day long. The clicking that you're maybe hearing, it's also from my analyzer because it's just going crazy here when I do that. But the clicking from the relays, you could barely hear it on the unit. I mean on the selector board. What you're going to be hearing next, and this is going to be a little louder, is switching the speaker relays in the back. So if I turn the speaker relays off, no problem. Obviously, you know, changing those speaker relays out. But let's look at the selector between the two channels, which works 100% of the time without any hiccups whatsoever. This, you know, that's why when I'm showing you the sine wave, that's because that's in place of a speaker right now. And so if the cracking and popping and zapping of that sine wave, you would show up, that's exactly what would go to your speaker. And that's what happens when you have intermittent contacts or little sparks happening on the contacts of the original connectors, which are open air connectors basically, where right now everything is done via those sealed low signal relays. So there you have it. This unit has been given a new lease in life. I'm thinking it's going to run at least for another 4 years. You know, we've run on for 40 plus years on original components. Every component I replace is better than the original. I gave it a new, well, not a new function. I made sure the original design functions correctly now and doesn't die in 10-15 years. Doesn't need cleaning. I know the owner. I'm hoping it's going to be happy. I think this is going to give him back the joy and bring back the memories of the day he was at the recording studio. That's what I hope for. But anyways, there you have it. I will possibly post a link to a website I'm thinking to put together, where I will share some of my rebuilds, in-depth details, and some close screenshots of some of the changes that I made. Also, maybe posted additional B2 Yamaha B2 rebuilds, or maybe rebuilds of other gear. I have a lot of other vintage gear that I maybe doing repairs and restorations on. Maybe sharing those details with the broader audience. If you found it that this video was interesting and you would like to give some feedback, please go ahead. Thank you very much for the time that you spent to watch it. If you didn't think it was interesting, then you know, maybe you'll find other ones that will be of your interest. Right. Until next time. Bye bye.